Hey Chivis, I'm Iwe, and today we are talking about a home elevator that finally lets a wheelchair-using teen reach his own bedroom. If you enjoy stories like this, hit the like button and subscribe if you haven't already. Let's go. In a two-story American house, a teenager reaches his bedroom by leaving his wheelchair at the bottom of the stairs and pulling himself upward. He has repeated that journey for years. Today, the question is not whether an elevator can fit inside a home. It is whether a home can finally fit the life of the person living in it. This is the story of one residential retrofit, but it is also a story about structural beams, public policy, family budgets, and the difference between being inside a house and being able to move through it independently. Act 1. The staircase is the first barrier. The young man at the center of this project is 13. According to his own account, he has used a wheelchair since about the age of 2. His family has lived in this house for roughly 6 years, and during that time, the upstairs bedroom remained separated from him by a flight of stairs. The workaround was physical, repetitive, and exhausting. He would transfer out of his chair, crawl upward, and then continue through the house without the chair that normally gives him mobility. Reaching the bedroom did not end the problem. It simply moved the problem from the staircase to the upstairs landing. For him, stairs were not an occasional inconvenience. They were the largest obstacle in daily life. That distinction matters. A visitor might see a staircase as one feature of a home. A wheelchair user can experience the same feature as a boundary that divides the house into usable and unusable territory. His ambitions extend well beyond the house. He plays wheelchair basketball and hopes to compete at an elite level with long-term aspirations connected to United States national competition and the Paralympic Games. Those goals are his own stated ambitions, not a guarantee of eligibility or selection. The relevant rules depend on sports organizations, classification, and federation requirements. The central issue is larger than one athlete's routine. Many homes were built around the assumption that every resident can climb stairs, step over thresholds, and use narrow doorways. When that assumption fails, the building often has no backup plan. A first-floor bedroom might solve the problem. A ramp might solve it in a single-level home. A stair lift might be less expensive than an elevator, but every option depends on the floor plan, the user's transfers, available space, safety requirements, and the family's resources. There is no universal retrofit that works for every household. There is also a financial reality. Medicare generally does not pay for home modifications, while Medicaid assistance varies by state and may depend on waiver programs and eligibility rules. Some veterans, older adults, and people receiving state services may find specialized funding, but access is uneven. For many families, a major modification becomes a private expense, a grant application, a community fundraiser, or an unusual sponsored project. That means the accessibility of a home can depend less on what engineering can accomplish than on who can pay for the engineering. Act 2. Turning a house into a machine. The installation begins with an ordinary-looking room below the bedroom. The living room ceiling is directly under the proposed elevator location, making the vertical route possible. That alignment is helpful, but it does not make the retrofit simple. A through-floor elevator requires an opening cut through the upper floor. In a wood-framed house, the floor is not just a surface. It is part of a system that transfers weight across joists, beams, walls, and foundations. Removing even a section of that system means redirecting the loads somewhere else. Before the cutting begins, the ceiling below is open. Electrical wiring and heating or cooling ductwork occupy the space where the elevator needs to pass. Those services must be relocated or adjusted. A closet is demolished upstairs, and the bedroom wall moves toward the hallway to recover some of the floor area consumed by the elevator footprint. This is one of the defining facts of residential retrofitting. The elevator may occupy only a small vertical shaft, but its consequences spread sideways through the house. The structural sequence is equally important. A temporary support wall holds the framing, while sections of the floor system are removed. New reinforcement and joist hangers transfer the load toward a larger supporting beam and the surrounding walls. The temporary supports are not decoration. They are part of the controlled sequence that keeps the floor above supported while the permanent structure is changed. This is why a project like this is a construction case study, not a weekend installation guide. The exact design depends on the home, the roads, local requirements, and qualified professionals who can inspect the structure. Once the opening is framed, a steel ring beam surrounds it. Two long aluminum rails run vertically from the living room floor toward the ceiling above. The elevator cabin travels inside those rails, with rollers following their internal tracks. The arrangement is closer to a guided carriage than to a conventional commercial elevator with a separate shaft. The motor is mounted at the top of the rail assembly rather than inside the cabin. An electric hoist raises and lowers the cabin through the opening. The system described for this installation uses ordinary household electrical service, and a nearby battery is intended to provide enough emergency operation for descent during a power failure. The stated capacity is about 500 pounds, but capacity must always be confirmed for the specific model and installation. The same caution applies to brand names. Residential elevators come in several families, including cable-driven, hydraulic, pneumatic, and other through-flow designs. The mechanical details here do not establish a manufacturer by themselves, so the equipment identity should be verified from its documentation rather than guessed from appearance. Act 3. Safety is part of the architecture. A lift that moves through a family living room has to protect more than the passenger. It must account for people, pets, toys, furniture, and anyone who might not realize that the space beneath the cabin is active. The described system uses pressure or weight sensing beneath the cabin. If something is detected below during descent, the cabin is designed to stop. A platform or a trapdoor on top serves a similar purpose during ascent. Weight on the surface should trigger a stop before a person or object can be pushed into the ceiling. These features are not substitutes for supervision, installation standards, maintenance, or careful use. A safety sensor can reduce a particular risk, but it does not make an elevator impossible to misuse. Doors, controls, clearances, emergency procedures, and inspections all remain part of the system. The cabin can also be called or sent remotely when the doors are closed, depending on the control arrangement. That matters because the user needs the wheelchair on the same floor as the cabin. A lift that only moves a person but leaves the chair behind would solve very little. The final finishes conceal much of the disruption. Drywall is repaired, carpet is removed and reinstalled, and the new opening is integrated into the room. When the cabin retracts upward, a bottom plate closes the opening in the living room, leaving a nearly flush surface below. That detail reveals an important design trade-off. The elevator is highly visible while moving, but when stored, it can reduce its footprint. The rails remain part of the room, yet the floor below can return to ordinary use. Act 4. The ride changes the map. The first ride is quiet compared with the construction. The teenager enters the cabin, closes the door, and begins moving upward with his wheelchair. The trip is short, but its meaning comes from all the trips that came before it. For the first time in this house, the chair travels with him between floors. The upstairs bedroom is no longer a destination reached by crawling. It becomes part of the same continuous circulation route as the living room. The physical independence is specific, not absolute. He still depends on a working machine, electricity, maintenance, and a home that can support the installation. But independence rarely means doing everything without assistance. Often, it means having a reliable choice about when assistance is needed. That distinction is easy to miss in conversations about accessibility. A ramp, lift, or elevator does not erase disability. It removes one environmental barrier and gives the person more control over the rest of the day. The project was sponsored, and that funding made this particular transformation possible. Sponsorship can bring attention to accessibility and demonstrate what a retrofit looks like. It can also hide the ordinary question that follows: how many families could pay for the same result without a sponsor? Installed home elevators commonly reach tens of thousands of dollars, with some projects exceeding $50,000 depending on equipment, structural work, finishes, and local requirements. Those figures vary, so a real project requires current quotes. A straight stair lift is often far less expensive, commonly in the range of a few $1,000s, but it may not suit every wheelchair user or every staircase. A first-floor accessible bedroom could have avoided the elevator. A stair lift could have changed the staircase. An addition could have created new space. The available evidence does not establish every reason those alternatives were rejected. The meaningful point is that accessibility decisions are also family decisions involving privacy, square footage, routines, preferences, and money. And the choices look different in rental housing. A tenant may not own the structure, control the floor plan, or have permission to modify it. For that person, a private elevator may not be an option at any price. Act 5. What the elevator reveals. The elevator is a successful intervention for one household. It should not be mistaken for a general solution to inaccessible housing. Universal design asks a different question from retrofit engineering. Instead of asking how to adapt a building after someone is excluded, it asks how buildings can be planned from the beginning so that more people can use them. Wider routes, fewer level changes, usable bathrooms, and adaptable rooms can benefit wheelchair users, parents, visitors, and people aging in place. The United States has accessibility protections for many public spaces, but the Americans with Disabilities Act generally does not require private single-family homes to be built like public facilities. Housing laws and funding programs address parts of the problem, yet they do not guarantee that every owner-occupied home can receive a major modification. That leaves a gap between the right to participate in public life and the practical ability to reach one's own bedroom. The aging population makes that gap even more consequential. Homes built for a narrow idea of mobility eventually become difficult for many residents, whether because of disability, injury, or age. A staircase can turn a familiar home into a place that demands relocation precisely when relocation is most disruptive. The engineering lesson is straightforward. A residential elevator is not simply a box inserted into a floor. It is a coordinated change to structure, circulation, safety systems, electrical services, and household space. The social lesson is harder. If a teenager can regain access to his bedroom only through a rare sponsored build that is a personal success pointing toward a public failure, the technology exists. The unanswered question is who gets to use it. A home should not require extraordinary luck before every resident can reach the rooms that belong to them. For this family, the elevator closes a daily gap between floors. For everyone watching, it offers a measure of what better housing could make normal rather than exceptional. If this case study raises questions about accessibility, compare the engineering with local building requirements and disability-led design guidance. And if you found the broader housing question useful, consider subscribing for more evidence-based stories about the technology people use to move, live, and participate.